Hello everybody, welcome to the third session of CPT scanning technology.
After the coating is conducted, and once the metal is made, the metal sheet is prepared, the metal sheet is coated with either internal lacquer or external protective or decorative lacquer or protective lacquer. The next step is basically the can making process. So in the case of cans, there are basically classification like there are 3-piece cans and 2-piece cans. So 3-piece cans was initially when it is developed, like it has three parts basically. It has a body cylinder is there, cylindrical can body is there. It has a top lid and it has a bottom lid. So this is the three parts of a 3-piece can. In the case of 2-piece can, the body is drawn using different kinds of dies. So it has only a cylindrical body and a top lid. So only two pieces are there. So that is why there is a classification like 2-piece cans and 3-piece cans. Initially, it was only 3-piece cans available. Later, when this drawing technology developed, so there we could make 2-piece cans as well. So basically, based on the number of components, the metal can be divided into two. That is 3-piece cans and 2-piece cans. So 3-piece cans are basically two ways it can be prepared. Either it can be welded side seam or it can be soldered side seam. These are the two methodologies available at that particular period to make these 3-piece cans. And also double seaming for both ends. So both ends the double seaming technique has to be applied since it is a 3-piece can. So there's a can body is there, cylindrical can body, which is made either by using a welded side seam or a soldered side seam. And finally, it has to be welded because it has top lid and bottom lid. Both the top and bottom lid has to be double seamed to the can body. But in the case of 2-piece cans, it is either drawn and redrawn method or drawn and wall iron method. Either DRD or DWI method is used for making that container. And finally, it is double seaming of the can lid. Only one double seam is required for 2-piece can. This is the methodologies available for can making. In the case of 3-piece cans, the cylindrical body with soldered or welded that we already discussed. So basically, it starts with a basic metal sheet which has to be converted into a cylinder can body. So the basic metallic sheet is called body blank. It is cut according to the size of the container. So all corners are exact right angles. That is what the peculiarity of this body blank. The body blank is converted into a cylinder using a flexing machine. The flexing machine is used to basically to remove the irregularities and flatten it perfectly. So the next procedure after the flexing is basically it's a notching procedure. So what happens is like when locking the side seams has to be locked together to make a cylinder. So what happens is the mid region when the two metals are overlapping, so additional bulging may occur. So in order to prevent that additional bulging in the side seam when we are overlapping two metal layers, for that purpose this particular notching is given. So basically there we will have only two layers of metal to reduce the thickness. That is why this notching is done. Notching is basically cutting the container so a perfect interlocking can be made on the side seam. But in the case like if you don't do notching, what happens is the side seam will have three metal layers. So that will eventually increase the thickness of the can seam. So in order to reduce that, the notching is done. If the notching is done perfectly, what happens is that the side seam will have only two layers of metal, which will significantly reduce the thickness of the side seam. So that is why notching is very important. And after notching, the edging is done. So edging is also very important because in edging, what happens is that a hook is formed by the the body edges, both the ends of the cylinder. There is a perfect hook is formed. That hook area will basically overlap each other. So these hooks are basically coated with a flex so that it can be either soldered or welded. So the cylinder is formed by either locking the hooks and either soldering or welding is done. So the locked hook after this notching and hooking is done, the locked hook is hammered and a second coat of flex is applied and soldered in a solder mill or either it is welded. And it is after that it is polished to remove excess solder because the soldering component is basically made with lead and tin. So it excess things has to be removed. These kinds of either soldering or welding, what happens is that some kind of lead and tin, whatever that is used in the soldering material or the welding process, this can seep into the food, resulting in lead poisoning. That is why this kind of 2-piece cans has been developed. So usually now the food cans are most preferred as 2-piece cans because this soldering and welding can actually spoil the food containers. Then after this method, initially, but it was a process. Either it has to be soldered or either it has to be welded. Initially, that was the process. But in those cans, this kind of lead poisoning and risk was associated with that. And after soldering, it needs to be polished to remove the excess molder, as we discussed earlier. Also, these cans were given circumferential beads for larger strength. To increase the strength of the container, circumferential beading was given surrounding the can. And also, last one is flanging. Like flanging, there is a flanging machine is there. The flanging is done on both ends of the container in the case of three-piece can, where the particular can neck is created so that the lids can be properly attached or properly double seamed into the can. That is the final process. Then after flanging, the soldering of the side seam has to be, because soldering, we already told that when soldering there is a tin lead solder is used. It's a ratio of 2:98. So, but there is a risk of migration to food of these components. So, US FDA 1995 prohibited soldering on food cans. Non-food cans, now again soldering is used. And also there is a welded side seam is there, because welding is basically the overlap hook is formed and require a less metal because than soldering. Soldering we needs more metal, but in the case of welding, a less metal can be used. It is stronger. It is like finish is also very good. So basically, in the welding there is a metal, another metal, a highly thermosetting metal has to be used. So usually normal use a copper wire welding, where copper is basically intermediate electrode. So it has a higher temperature around 900 degrees Celsius. Copper is basically material, the metal that is going to fuse the both the metal layers together. So either a welded side seam can be used or a soldered side seam can be used. In the case of two-piece cans, there are two main methods used commercially to make two-piece containers. The first one is the drawn and iron method, or DI process, which can be adapted to produce a can for pressure packs, including carbonated beverages, and for food containers, and the DRD process, drawn and redrawn process, which is a multi-stage operation and produces a can mainly suitable for food products. So DRD is there, D and I or DWI, drawn and wall ironed cans are there, or drawn and iron. It's also known as drawn and iron or drawn and wall iron, either DI or DWI. And another one is DRD, drawn and redrawn process. So drawn and redrawn processes is there. So basically it forms in a 5-stage process. So there's a body blank is there. So there is first initial drawing cup is there, converts into a drawn cup, and then also the drawing process proceeds into the third and fourth stage. What happens is the diameter decreases as the cup is redrawn. Diameter decreases, but the thickness will not change. The finished trimmed can with profile base can be after finishing. So fifth stage will be the finishing process, where the profiling will be given to the base so that it can be properly stacked, and the proper pressure resistance will be achieved by the container. Both the drawn and redrawn technique and drawn and wall iron technique was developed for aluminum cans in 1950s and for the tin plate cans in 1970s. The main advantage is that either the two-piece cans, which is made using DRD method or DWI method, it does not have no side seam or bottom seam is there. So what happens is that it has more structural integrity, because the weakest point in any container is where it is the joining point. So only one join is there, which is the lid. So it has also higher advantages compared to the soldered or welded cans, that it requires 35% less metal. Since it requires only 35% less metal compared to soldered and welded cans, it is lightweight. The weight is significantly reduced. That is one of the advantage. And also absence of side seam will provide a better printing area. So the look of the container is also better compared to other three-piece cans. In the case of DRD process, what happens is that thickness and surface area of the metal does not change. Only the diameter changes, and it is always going to be equal to the body blank that is used. Around 2 mm thickness sheets are used in the case of DRD containers. So the basic difference is that only the diameter change is equal to the body blank. So thickness and surface area of the metal does not change. So that is one of the peculiarity. In the case of drawn and wall iron method or DWI method, it is basically an extension of DRD. So additional steps are added after drawing. And it is in the case of DWI or wall ironing method, diameter does not change. Basically, the wall thickness decreases. That is one of the important peculiarity of wall ironing. That is from 0.3 mm to 0.1 mm. The thickness of the metal will change from 0.3 mm to 0.1 mm. So, but the body height usually increases. The bottom will be of same thickness. The bottom is going to be same thickness, but in the case of, that is why it is called as wall ironing. The wall thickness reduces from 0.3 mm to 0.1 mm. But the bottom thickness will be the same as that of the base plate. The diameter does not change, but the height of the container or wall thickness changes. In the case of DRD, the thickness of the wall does not change, only the diameter is going to be changed. So that is the difference between drawn and redrawn and drawn and wall ironed. So in the case of wall ironing, a synthetic lubricant is applied which is washed later, because for ironing the wall, the process has to be really smooth and flawless, so that, for example, in the case of metals are ironed, or like metals are pressed through rollers, or certain dyes are used to reduce the thickness of the metal. Normal, because metal friction can happen, and which may result in the destruction of the metal surface area. So, in order to prevent that, a synthetic resin or synthetic lubricant is added in the case of wall ironing. So, mostly all of the beverage cans are basically prepared using drawn and wall ironing process, or DWI process, and the food cans are basically used the DRD process. One of the important component other than the body of the container is the lid. So can is also known as can end or can lid. So in the case of can end, if you watch closely, you can show different kinds of consecutive rings, ring-like structures are there. This is called as expansion rings. So these expansion rings are to counteract on the deformation of the container when there is heating and cooling. That is why these expansion rings are added. So they deform according to the internal and external pressure. So this deformation will provide the container to withstand the pressure. And also the sealing area of the container, where the container is double seamed with the can body. So there is a sealing, rubber based sealing compound is added. The composition of the compound is it is 20 to 25% rubber, and it is around 50 to 75% filler and pigment is there. 10 to 25% resin is there. Less than 1% plasticizer and less than 1% antioxidants are also added. So such kind of sealing compound is generally added on the exterior compartment of the lid, so that when during the double seam and heat application, this resin will eventually fill the gaps between the double seam, so that so a perfect seal can be formed around the container. One of the most important processes is the sealing the container. So preparing a perfect container with a perfect material that we discussed, that certain metals has to be used, certain quality metal has to be used, certain lacquer coatings has to be given to the container, certain manufacturing methods we have to follow to make the container in a particular shape or the desired shape. But the success of the process depends on how the food is enclosed within the container, how it is hermetically sealed or sealed in an airtight manner. One thing is that it should withstand the expansion pressures during the process, and it should not leak. The container should not leak. Any faulty sealing methodology can result in leakage of the container post process, and eventually it will result in post process spoilage. So to prevent that, a proper seaming technique has to be used. The normal seaming that we use is earlier, that the soldering and welding is not currently used. The seaming process, that to connect the lid with the can body, the process is called double seaming. There are double seaming machines are there, different parts are there. Chuck is one of the part which is going to rotate, and there is also a base plate or a turntable that is used where the container is going to be placed, and there is a rotating chuck which will be holding the container and the lid together, and there is going to be two seaming heads. The first roller is also there, and second roller is also there. So first roller is going to be a kind of blunt end, and the second roller is going to be a more sharp in nature. What happens in the sealing process is that first the blunt or roller or the first roller will come in contact, and this will basically just roll up the layers of the can lid and the can body. And after the first roller detaches from the seam, the second roller will come in contact. The second roller is more sharp in nature. The purpose of the second roller is to flatten the curved rolls so that perfect seam can be formed. First roller will curve the metal layers, and the second roller is going to flatten it up. So that is why there are two steps are there in the seaming. That is why it is called a double seam. There is first roller seaming, and there is also a second roller seam. So in this you can watch that like the double seaming happens in a different stages. The first basically end, the can end and the body are brought together, including the lining compound is there. And first it will rotate that, and second seaming operation that it form a curve nature. Then there is going to be a first seaming operation, and there is going to be second or final seaming operation. So this kind of two seaming operations are going to happen. And a perfectly formed seal will have 5 layers of metal. There is going to be 3 layers of like a lid metal and 2 layers of can body. So that is why total a perfect seam will have a 5 layers of metal is going to be there. So different parameters, if you take a cross section of a perfect can seam, double seam, you can see different parameters such as seam thickness is there, seam gap has to be measured. The overlap is one of the most important parameter in the case of a double seam. So if you measure the overlap should be more than 40%. It should not be less than 40%. So a perfect double seam, the overlap should be more than 40%. So overlap is there, end hook length, the depth is called as a countersink depth, body hook length. So these kind of different kinds of parameters can be measured from the cross section of a double seam. The lid of the container has gone through different kinds of modifications, because the main issue with the lid, once it is double seamed, is that it is impossible to open. So we need to use special kinds of tools basically to open the lid. Earlier it was like using a hammer or a chisel. We need to strike the cans open. Still also such kinds of can containers are there where you need to use different kinds of tools are there, and also different kinds of can openers are also available which will cut through the lid so that we can open the container. But it was basically to carry an article or a can opener, etc. Eventually, what happens is that people find it difficult to carry an additional article to open the container. They were interested to just to open that. The opening process was very difficult. So, what happens is that the first initial invention was made by Hermel Cleon France, 1962. He invented the pull tab. So, that was the first attempt made by Hermel Cleon France in 1962. It was known as a pull tab, but the issue with pull tab is that once you pull the tab loosens, and it is a metal end was separated from the lid. So what happens is that this kind of pull tabs created a wastage problem, because wherever the people will go, they will once the container was opened, this tab was very difficult to to dispose, and it caused different kinds of hazards. Oh, especially in the beaches, and all these tabs started to corrode, and people got damaged, like different kinds of wounds by stepping on such tabs in the beach. So such issues was created, and finally a solution was proposed by Daniel F. Kudzik in 1975. He invented the stay-on tab. So still now we use a stay-on tab for opening the containers. The stay-on tab is like the basic physical civet methodology that uses if you pull the container in a particular direction, and particular pressure is created in the opposite direction, and due to that extra opposite that pressure, that it will basically break the surface of the previously glued can lid. So the advantage is that the stay on tab will stay on the container and the lid itself. So it was easier to dispose that way. So now we have easy open ends. It's called easy open ends or EOES cans. Initially it has pull tab, and finally in 1975 the stay on tab was invented. After sealing the cans, the next important component in the case of industrial aspects, it is called the metal can dimensions. So the dimensions of the container has to be like standardized depending upon the type of food we need to put, and based on consumer preferences as well. So metal can dimensions, like earlier it was like only round cans were there, and also oblong cans were there, also known as F style cans. So in the case of round cans, they are shown as two sets of numbers. The round can dimensions were shown as two sets of numbers. The first set of number is the can's diameter, and the second set it is height. So that was the basic dimension that was used for round cans. In the case of oblong cans, are shown as three set of numbers. The first set of numbers is the can's length, the second will be the width, and the third set is the height. So other kinds of other than round cans, this was the method used. The expression of these groups of 3-digit numbers are unique to metal cans in the case of United States. In the United States, this kind of dimension is used. This number is the dimensions in whole and 16th of an inch. So that now the industry standard is that use it as a whole number and a 16th of an inch of that number. So the first digit indicates the number of whole inches, and the second and third digits indicate the fractional inches as 16th of an inch. So to demonstrate how this looks, for example, a round can with a size listed as 307 into 512, it would be 3 and 7 by 16th inch in diameter, and by 5 and 3 by 4th inch in height. So in the case of can dimensions, we use this kind of methodologies. For example, another example if we can discuss, that is 303 into 406 containers are there. So What you mean by 303 is that it means it is like 3 inches into 3 by 16ths. That is 303. 3 inches and 3 by 16th into 4 and 4 6 by 16th inches. So this is the dimension methodology. Like dimension of the can containers are expressed in one whole inch number and followed by a particular number. That number divided by 16th ratio. That means inches. So it is expressed in such a manner. And there are different kinds of popular seafood can sizes, which is widely used throughout the industry. So the most common type of can is that the standard size is called 307 can. Why it's called 307 can means it is the dimension is 307 into 109. So it is the capacity is around 170 grams. So that is a standard can used throughout the world. And also different kinds of other shaped cans are there. For example, 1 by 4 club cans are there. So approximate dimension of a club can is around 104 mm length and into 59 mm width into 28 mm height. So several heights, that different heights will be there. So these kinds of club cans are basically used for sardines, mackerel, etc. So it has a particular shape. And also another common name Dingley can is there. So approximate dimension of a Dingley can is 105 mm length, 73 mm width and 24 mm height. So it is also used for this kind of cans, sprats, herrings, etc. depending upon the can size. And also there are oval cans are there at an approximate dimension of 105 mm length, 64 mm width and 30 mm height. And also used in different kinds of seafood preparations. There is also another kind of can called Hansa. This is a trade name. So Hansa has an approximate dimension of 148 mm length. It has 81 mm width and also 22 mm height. And it is used for sprats, herrings, fillets, mackerel. So all these kinds of different cans, like standard 307 can, it can be a standard club can, standard Dingley, standard oval, or standard Hansa. These are all trade names that is used. These cans have different kinds of different dimensions, different shape, and that according to the consumer preference, according to the seafood material that we are going to fill in the containers, according to the label design that we are going to use, any industry can choose from different can dimensions. Other than can dimensions, there are certain improvements to the structure of the containers that has been made to improve the physical properties of the containers. Like just like high tin fillet cans are there, light tin coated cans, grade K tin plates are there, Litwell N or LTWN cans are there. So different kinds of modifications. For example, in the case of beaded cans are there. Certain beaded cans are made. Beading is done to reduce the cost. Metal can be used, has to be used, but the strength can be increased. In leading in different kinds of higher size cans can be prepared with a lower amount of metal. So that is why this like a beaded cans are there. Side beadings are given in order to increase the physical strength of the container. Compared to other containers, less metal can be used. That is called beaded cans. And also there are cemented side seam cans where polyamide adhesive is used for sealing. Instead of double sealing, that a particular polyamide adhesive is used. In the case of it is normally used in tin-free steel cans, TFS cans it is used. It has better printability because we are not using any sealing agent. So there is no double seaming or metal overlapping or metal binding is used. Only a polyamide adhesive is used so that it has a better printability and better look to the container. There are also high tin fillet cans or STF cans, which is widely used in the canning of spinach and tomato, basically high acid foods. So what happens is that high acid foods which have additives such as oxalates and nitrates, they have a de-tinning effect. De-tinning effect means the tin coating is removed because of these components. So it is going to be affect the product color, etc. So an extra tin fillet is added. Extra tin fillet is provided which acts as a sacrificial anode. De-tinning effect will be from the fillet other than the can. So it is called a high tin fillet cans. And there is also light tin coated steel or LTS cans. It is basically a very thin layer of tin is used. 1 GSM tins are used. The lowest is around 5.6 GSM. Is further protected with chromium coating, and chromium oxide. But it is lesser than because it is like lightweight tin is used. It is not tin free steel, but a small quantity of tin is still used. That is why it is called light tin coated steel. It is still a TFS can with chromium coating is there with an additional small amount of tin, but lesser than other normal tin cans. That is why it is called a light tin coated steel. And also grade K tin plate is the tin coating of 0.75 pounds. That is 16.8 GSM of tin coating is instead of normal 1 pound which is 22.4 GSM. Normal can, you will find a 1 pound coating, that is 22.4 GSM coating. In the case of grade K tin plate, we will have a 0.75 pound coating or 16.8 GSM coating. And there is also Little N or LTWN containers are there. It is also a less tin container. It is having a nickel alloy layer between tin coating and steel. There is a nickel alloy layer is there. It gives additional corrosion resistance, weldability, and lacquer addition than tin plate. So it is an like enhanced property than normal tin plate. And also there is another kind of containers like aluminoid steel. Because steel, it is basically steel only, which is hot dipped coated with aluminum, and aluminum and silicon base is used. An additional coating with aluminum silicon alloy is used for protect the steel. So it is called aluminoid steel. The advantage is that it will be having both the properties of steel as well as aluminum. The next important packing material is basically the flexible packing material, which is called the retort pouch. Either it is known as retort pouch or retortable pouch. The retort pouch was invented by the United States Army NATIC R&D Command, combination with Reynolds Metals Company and the Continental Flexible Packaging, who jointly received the Food Technology Industrial Achievement Award for its invention in 1978. So the retortable pouches or retort pouches are extensively used by the US military for field rations, also known as meals or meals ready to eat or MREs. This pouch was developed by the US Army. Now, mostly all the military, they are using this kind of retortable pouches for carrying their military ration. Even though it is initially used by the military, and slowly now we can see the many consumer products are also using the same technology for ready to eat products using this flexible packaging called retort pouches. Because it is flexible material, the transfer of heat transfer ratio is comparatively faster than compared to the rigid metal containers, where it has to go through conduction convection processes, cycles of conduction convection processes. But the conduction in the case of flexible pouches are faster because of the reduced thickness and the material. So the processing time is reduced to 60% than metal cans. It has better quality of the food. Rapid heating by consumer before eating. It can be easily heated by the consumer before eating. And weight and space is also saving, because compared to metal containers, these are the major advantages of using a retort pouch. And normal retort pouch, there will be different layers are there: 2-ply, 3-ply, 4-ply layers are there. 2-ply, normally it can be used inner polypropylene layers will be there, either a top nylon layer, an aluminum foil, and external polyester layer. So this is the normal layers of a standard retort pouch. In the case of 2-ply, there may be a 12 micron nylon or polypropylene and 70 micron polyolefin. In 3-ply, it is 12 micron polyethylene, 9 to 12 micron aluminum foil, and 70 micron polyolefin. And in the case of 4-ply, it is going to be 12 micron polyethylene, and 9 to 12 micron aluminum foil, then 12 micron polyethylene, and around 70 microns polyolefin. So this is dependent upon whether it's a 2-ply, 3-ply, or 4-ply. Different kinds of materials will be added. But in any cases, the innermost material is going to be polypropylene, because polypropylene is the food safe material, food contact surface. It's a neutral plastic, so it is always the innermost layer where the food contact comes. And then aluminum layer is used. Nylon, sometimes used nylon, or without nylon also pouches are there. Nylon gives the mechanical properties are there, and aluminum foil gives the barrier properties. And also the external polyester layer will give the abrasion resistance and printability, etc. So these are the functions. And there are also two types of retort pouches. Transparent retort pouches are there, and there is also opaque retort pouches. Opaque retort pouches will be usually made with aluminum foil inside. Then transparent retort pouches can be produced by replacing the aluminum foil layer with a silicon dioxide or some like a transparent material, which will have same barrier properties as aluminum. But in the case of opaque retort pouches where aluminum is there, the consumer cannot directly put the pouches inside a microwave oven for heating. But in the case of see-through pouches, since it is without aluminum foil, instead of aluminum foil, we use silicon dioxide and other kinds of similar materials. It can be directly heated after opening in a standard microwave. If you see the advantages and disadvantages of retort pouch, first, if you see the advantages, because of the thin cross-sectional profile, heat transfer is rapid. There will be 30 to 40% saving in processing time. No overheating of the product takes place near the package walls, because in the case of metal cans, since it is a conduction, because the metal walls will heat more than the inside container. So the food which is in contact with the exterior of the can, which is in contact with the can wall, can subject to overheating or overcooking in the case of metal containers. So that risk is not there in the case of retort pouch. And because of the reduced exposure to heat, loss of color, flavor, or nutrients is minimum. And shelf life is equal to or better than that of foods in metal cans. The empty pouches require only very little storage space compared to empty cans, and also pouches are easy to open as well. There is also certain disadvantages to the retort pouches. The main disadvantages are the pouch seals are more vulnerable to damage than the metal containers and hence require individual overwrap. The packaging cost is going to be more in the case of retort pouches because they require an additional, like a cardboard or paper covering for protection. And with an overwrap, the cost of the pouches may become higher than that of metal cans, that as we discussed earlier. It also have a slow rate of production. In the place of handling 300 to 400 cans per minute, the pouches line can handle only 30 pouches per minute. So the rate of production is very less. It also needs special retorts for thermal processing because the pouches cannot withstand the internal expansion like metal cans. So they will need an additional overpressure of 5 psi. So the total pressure needs to be applied is 20 psi when the metal cans needs only 15 psi to operate. So we need additional overpressure retorts for preparing retort pouches. So in a retort pouch, a thermosetting adhesive is used to band the layers. The different kinds of layers has to be bonded together. So there's a thermosetting adhesive is used. It is also usually it is like polyethylene isocyanate is the normal thermosetting adhesive as used. The seal is made by thermal fusion of polypropylene layers. It is basically a thermal seal using a thermosealing machine. The edges of the pouches are fused together when there is a thermosetting adhesive like polyethylene isocyanate is also added. And also different terminologies are the pouch body is there. Pouch body is basically the area of the pouch located within the sealed area. The outer border of the retort pouch will be sealed, and inner body is that it's called the body is area within the sealed area. And also side seals are there, like or manufacturer's seal. It's called manufacturer's seal or side seals. So basically, three numbers of side seals with the 3 mm width is normally there, and top will be open to add the food, and after adding food only the main seal is applied. Well, there is also a cosmetic seal, a seal applied by the processor called a buffer zone outside the main seal or the hermetic seal. The cosmetic seal is also there. There is a hermetic seal. It is like a seal to prevent post-process spoilage or process seal. It is also known as a processor seal. And also tear notches are given on the sides for easy opening of the container. There are different kinds of tear notches depending on the thickness of the material. There is V notches, U notches, and C notches are given according to the type of the container. And pouch sealing machine is used to usually a thermo sealing machine is used. And there are different dimensions. There is around different types of A grade dimensions, A sizes, B sizes, and C sizes are there. So different kinds of length into breadth is the only dimension that is matters in the case of retort pouch. Naturally, it is at 130 into 160 pouches are there, 130 to 200 like that, or 150 or 170. Different dimensions are there. So one of the most important packaging material that is used along with the flexible retort pouch is that it's called a Tetra Pak. Tetra Pak is basically, it was invented by Anders Ruben Rosing, who lived in 1895 to 1983, and the co-inventor was Eric Wallenberg. So these two were responsible for the development of Tetra Pak. So Tetra Pak is basically a multinational company based in Sweden. It is founded by these two gentlemen in 1944. Before, the company was known as Akerlord and Rosing, and after the invention of Tetra Pak, the package name was taken by the company as a company name. So it is the tetrahedron packaging that was initially developed. It is basically like four sides packaging. It's aseptic packaging technology, and is also known as ultra high temperature short time processing. The process we will discuss in the later sessions. But the technology is used mostly for preparing the liquid foods like fruit juices are there, milk products are there. Mostly such kind of liquid materials are used. It is also known as ultra high temperature short time processing or aseptic packaging technology. Even though the initial container was tetrahedron with four sides, but eventually the Tetra Pak company evolved and they developed different kinds of packaging materials. So now the most popular one is Tetra Brick Aseptic Packaging Components or TBA. It is like different six layers of materials are there. Two layers of polyethylene is there, then this aluminum layer is there, and again polyethylene, then paper, and finally polyethylene. So these are the six layers of a tetra packing material. Next comes the semi-rigid containers or thermoform trays. So thermoform trays are also known as semi-rigid containers, and different kinds of plastics are used like high impact polypropylene or HIP plastic is used, which is having high barrier polypropylene is used. High impact polypropylene is having a high physical strength. But for increasing barrier properties, we can use or high barrier polypropylene, different levels of polypropylene. And also there is multi-laminate traces there, like a polypropylene, ethylene vinyl alcohol, EVOH, polypropylene EVOH, polyphenyl, polypropylene EVOH, polyamide, like different kinds of materials can be used for preparing of the thermoform trace. It could withstand temperature up to minus 40 degree to 125 degree Celsius. So this is the extreme temperature range, minus 40 degrees Celsius to plus 125 degrees Celsius. That is the temperature range this kind of thermoformed trace or thermoforming materials can withstand.
Thank you.